This is lesson 3.2, and these are some really important vocab words, so I would suggest pausing this video and writing these vocab words down. So we have a rational number and irrational number. A rational number is a number that can be written as a fraction. Okay, so if it's a decimal, it either has to end or repeat. It can't go on forever. So it can always be written as a fraction. An irrational number can't be written as a fraction. So it's a decimal that just goes on forever, doesn't end, doesn't repeat. So this is some practice as writing each rational number as a fraction. So what we're going to do is we're going to take these mixed numbers and turn them to an improper fraction. So we do that by using the strategy of MAD. Multiply, add, keep the denominator. Multiply the whole number times the denominator, which is 2 times 5 is 10. Add the numerator. 10 plus 3 is 13. Keep the denominator of 5. So 2 and 3/5 is the same as 13/5. Multiply, add, keep the denominator. -4 and 3/8. Again, we're going to use MAD, but we leave that negative off until the very end. We just attach that to our answer. We just treat it as a normal 4 times 8. 4 times 8 is 32. Plus 3, because we add the numerator. 32 plus 33 is 35. And I keep the denominator. So we have -35/8. And then number 3 is -6. To change this into a fraction, all we have to do is put it over 1. -6 over 1, it's the same as -6, but now it's in fraction form. So to change a decimal to a fraction, all we have to do is read the decimal out loud and write it as it sounds, and then put it in simplest form. So here we have 4 and 53/100ths. We write it just like it sounds. 4 is our whole number, 53/100ths, 53 over 100. And then we always want to put it in simplest form. In this case, we can't divide anything on the numerator and denominator and make it any simpler, so this is our answer. So write 26/100ths as a fraction in simplest form. So again, we just write it as it sounds, 26/100ths. 26 over 100. And then we have to write it in simplest form. So I'm going to divide both by, let's start with 2. 26 divided by 2 is 13. 100 divided by 2 is 50. And I can't make that any simpler, so that's my answer. 13/50ths. The shipping weight of a package is 2 and 875 pounds. Write this decimal as a mixed number in simplest form. So again, we just write it as it sounds. 2 is our whole number. And then we have 875 thousandths. So I write that as 875 over 1,000. And then I have to write this in simplest form. So I'm going to divide both the numerator and the denominator by, let's start with 25. So I know 1,000 divided by 25. 100 divided by 25 is 4, annex on a 0, so that would be 40. And then, for sake of time, I'll help us out with the top. 875 divided by 25 is 35. And then I can divide each of these again by 5. 35 divided by 5 is 7. 40 divided by 5 is 8. So our answer is not 7/8, it's 2 and 7/8. I almost even forgot that whole number. So be careful, don't forget that, and then we can label it as pounds. All right, another good thing to have in your note is this Venn diagram of real numbers. So here's how it works. Natural numbers That's the first part of our Venn diagram. Natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to infinity. But it doesn't include zeros, no decimals, just those numbers that are whole numbers, but they don't include zero. So it starts at 1, 1 all the way to infinity. Then we add in whole numbers. Whole numbers are all those numbers, but 0 is included. So 0, 1, 2, 3, 4, all the way to infinity. Then our next layer is integers. Integers are whole numbers and they're opposites. So now we have 0, 1, 2, 3, 4, 5, all the way to infinity, and -1, -2, -3, -4, all the way to infinity. Then we add in rationals. Rational numbers are those positive and negative numbers with decimals that end or repeat, fractions. So maybe you want to add off to the side here, rationals, we have fractions, decimals that end, or repeat. So if you have a natural number starting at that very center, if it's natural, it's also going to be all of these. A natural number is a whole number, an integer, and a rational. You can't do that the opposite way. Okay, so a rational is only if it has like a decimal or a fraction that ends or repeats, only rational. You can't go the opposite. But if you have, so let's say we have, if it's a integer, so an integer is an integer and a rational. You can always go outwards from this, so it would be both. A whole number would be whole, integer, and rational, but like I said, you can't go backwards, so it's not also natural. Then our last one is irrational. Irrational numbers are decimals that go on forever, they don't end, they don't repeat. So pi is a good example of irrational because it goes on forever, doesn't end, doesn't repeat. So we're going to practice that. So it says identify all sets to which the following numbers belong. So 7 and 1/8. Well, it has a fraction to that, so I know it's not natural, it's not whole, and it's not an integer, but it is a fraction, which means this is rational. Letter B is 1.4142, blah, 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 repeating. Well, that goes on forever, it doesn't end, doesn't repeat. So it is irrational. And we know it goes on forever because that ... that indicates that it doesn't end. Then we have 15. So looking at our Venn diagram, 15 is a natural number, which means it's also whole, it's also an integer, and it's also rational. So we write natural, whole, integer, and rational. Then we have -12. -12 is not natural, it's not whole, it is an integer, which means it's also rational. So it's an integer and it is rational. Okay, number 17 says an equation is shown, n equals 1 divided by 17. Which describes n? Is it an integer, irrational, rational, or whole? So 1 divided by 17 can also be written like this, 1 over 17.